All right, so we're going to use some substitution because right now this looks awfully complicated. So the first thing I want to notice is that my arguments match, okay? So I am just going to say that x equals sine theta, and all that's going to do is just make it easier to handle. So now I've got a 2x squared minus a 3x plus 1 is 0. And that's a whole lot friendlier, believe it or not. So I'm going to use slide, divide, slide to factor this. So I'm going to slide the 2 to the end. So I've got x squared minus 3x plus 2 is 0. That factors down to two numbers that multiply to 2 and add up to a negative 3 are going to be an x minus 2 and an x minus 1. But I slid over and multiplied by 2, so I need to balance by dividing by a 2 if it reduces, and then reduce it. If it doesn't, then slide that back up front. So 2x minus 1. So this is the factored form of the original one. So I'm going to take each one, because this chunk times this chunk is 0. Each chunk needs to get set equal to 0. And then solve. So x equals 1 or x equals 1/2. So that's all the algebra behind it, but remember, we substituted in and we said that x needs to be sine theta. So instead of x, I'm going to say sine theta equals 1 or sine theta equals 1/2. And then I did not look at the restrictions. Am I restricting this? Yes, to one lap of the unit circle. So where does sine equal 1? Within one lap of the unit circle. And that is going to occur at pi over 2. And then where does sine equal 1/2? And sine equals 1/2 at pi over 6 and at 5 pi over 6. So you've got 3 solutions, and just you need to check these. So take this back up in here, or in your original function, and check them, because since we're kind of sort of manipulating stuff, you just need to make sure that it works out, and you're always supposed to check your work anyway. So that is solving equations by factoring. Well, now let's see what else we can do. So I've got another one. I have 4 cosine squared. So 4 cosine squared x minus 2 is 0. And again, I'm keeping this restricted to one lap of the unit circle. There you go. All right, so I only have one trig function, and so I don't need to use substitution. I'm just going to get it by itself. I'm going to add 2, divide by 4. So cosine squared x is add 2, divide by 4 would give me 1/2, 2 over 4. And then I need to take a square root of both sides. So I now have cosine x equals plus or minus the square root of 1/2, which when you rationalize that, square root of 1 over square root of 2, you actually get plus or minus root 2 over 2. So I would like to know, where does cosine equal a positive or a negative root 2 over 2 within one lap of the unit circle? And that's going to be at pi over 4, 3 pi over 4, 5 pi over 4, and at 7 pi over 4. So again, you need to sub that in and check just to make sure, because at some point these are not going to work, okay? So let's do another one. We have cotangent theta plus 1. So cotangent theta plus 1 times cosecant theta minus 1. And that equals 0. So this has already been factored down for us. And again, we are restricted to one lap of the unit circle. So since it's already been factored, I'm not going to try and do anything fancy with it. I'm just going to say this thing can equal 0 or this thing can equal 0 and solve. So cotangent theta plus 1 could equal 0, or cosecant theta minus 1 could equal 0. So now solve. Where does cotangent equal negative 1? And where does cosecant theta equal positive 1 within one lap of the unit circle? So where does cotangent equal negative 1? So that's going to be in quadrants 2 and 4, which is going to be 3 pi over 4, and again it's 7 pi over 4. Where does cosecant equal 1? Well, cosecant is the reciprocal of sine, So where does sine equal 1? And sine equals 1 at pi over 2. So if you evaluate those, and again, just check your work. So shove in and make sure that either this thing goes to 0 or this thing goes to 0. And I know I'm going like Mach 75, but I'm trying to keep this into just 1 or 2 videos instead of 3 or 4. All right, so I've got a cosine x plus 2 sine x cosine x. Okay, so cosine x plus 2 sine x cosine x. And that needs to equal 0. So what I notice first off is that both of these have a cosine involved. I also notice that the argument is it matches. So I'm going to try and avoid trig identities as much as possible. So I'm just going to factor out a cosine. So cosine x times 1 plus 2 sine x equals 0. And again, I'm pretty dang sure we're restricted. So we're restricted to 1 lap of the unit circle. Okay, so this thing can equal 0. So where does cosine equal 0? Or where does 1 plus 2 sine x equal 0? Well, cosine equals 0 at, holy cow, no it doesn't. Cosine equals 0 at pi over 2 and at 3 pi over 2. Okay, so he has 2 solutions. And then this one, I'm going to subtract 1, divide by 2. So where does sine equal a negative 1/2? Well, sine equals a negative 1/2 at 7 pi over 6 and at 11 pi over 6. So you've got 4 solutions. Always make sure, go back and check. Okay, so far we have just done a bunch of factoring. And now we're going to introduce a new kind where we're actually going to have to make our stuff match. So our arguments match, sorry. Let me be a little bit more exact instead of mouthing off. All right, so I've got the sine of 2x equals root 2 times cosine x. So first off, I notice that my arguments don't match. So I want to see if I can somehow morph this into having the same argument, because that's going to help me out. So I do know this is a double angle. So if you go back to your double angle identities, I can rewrite this as 2 sine x times cosine x equals root 2 cosine x. Okay, so now I notice I got cosine. So I'm going to bring everything over and set it equal to 0. So 2 sine x cosine x minus root 2 cosine x now equals 0. Okay, so I can now factor from here. So I've changed it so that my arguments match. I used a double angle identity, and now I can factor. So I'm going to pull out a cosine x, and that's going to leave me with a 2 sine x minus root 2. Okay, so where does cosine x equal 0? And then where does 2 sine x minus root 2 equal 0? And again, we're restricted from 0 to 2 pi. So within 1 lap of the unit circle, this is going to be at pi over 2, and this is going to be at 3 pi over 2. This one I've got to solve, so I'm going to add root 2 and divide by 2. So sine x equals root 2 over 2. Well, where does sine equal root 2 over 2? That's going to be at pi over 4 and at 3 pi over 4. So you've got 4 solutions that will make this thing work. Okay, sorry. I'm trying to go at a decent speed, but not destroy people in the meantime. All right, so we've got 9 sine t minus 9 cosine t equals 9. So again, make sure you check your work because some of them may not work. So I've got 9 sine t minus 9 cosine t equals 9. Well, the first thing I notice is that I can kill a 9 out of everything. So I'm going to divide everything by 9. So now I've got 9, or sorry, I don't. I have sine t minus cosine t equals 1. Okay, so common sense, because the biggest ratio for sine and cosine is both 1. Okay, so common sense should tell you that this should be combinations of zeros and ones. But rather than just depending on common sense, we want to depend on math as well. So I'm going to square both sides. And so that's going to give me sine squared t, and then minus 2 sine t cosine t plus cosine squared t equals 1. Okay? Sine squared plus cosine squared is 1. Okay? So this, by a Pythagorean identity, becomes a 1. So now I have negative 2 sine t cosine t plus this 1 equals 1. So I'm going to subtract 1 from both sides. And so that's going to give me a negative 2 sine t cosine t equals 0. Well, now I can divide both sides by negative 2 and still get 0. So now what do I have? Well, one of these two things must equal 0. So this thing times this thing equals 0. So where does sine equal 0 and where does cosine equal 0? Within one lap of the unit circle. So sine is going to be at 0, pi, and not 2 pi because you're not allowed to use 2 pi. Okay? And then where does cosine equal 0? At pi over 2 and at 3 pi over 2. So you've got 4 potential answers. Check your work. So make sure, so shove in a 0. 9 times the sine of 0 is 0. Okay? Minus 9 times the cosine of 0 is 1. So this says 0 minus negative 9. Sorry. Oh, I just butchered that. All right, so 9 times 0 minus 9 times 1. So 0 minus 9 does not equal positive 9. So 0 is not going to work. Okay, so check your work. This is one of those cases where it's not going to work out so well. Let's see. Oh, wait a minute. Holy cow. Did I just, oh no, sorry, I flipped. All right, I got 3 more problems. Ha ha! I have faith. We can get this done. All right, so I've got cosine squared. So cosine squared x minus 6 cosine x minus 1 is 0. So first of all, I notice my arguments match, but this is squared and this isn't. So I'm just going to say, we're going to say m. Okay, it doesn't matter what variable you use. So m is going to equal cosine. So that means I have an m squared minus a 6m minus 1 is 0. So this isn't factorable. So you can use quadratic formula or you can complete the square, and I'm going to complete the square. So I'm going to kick my 1 over. So m squared minus 6m equals 1. Take half of this, which is negative 3, and square it, which is 9. So I just created a 9. And now I can factor this as an m minus 3 squared equals 10. Take a square root, take a square root. So m minus 3 equals plus or minus root 10. Okay, so I need to add 3. So m equals 3 plus or minus root 10. Well, what is m really and truly? M is really and truly cosine. So cosine x needs to give me 3 plus or minus root 10. Now, in your calculator, if you give me a decimal approximation, 3 plus root 10 is going to be 6.16 something or another. And cosine's ratio cannot be bigger than 1. So 3 plus root 10 does not work because it's outside of the range for cosine. So what is 3 minus root 10? 3 minus root 10 is a negative 0.1622. So now here's where it gets fun. You can graph this and find out where they meet each other. Okay, so where does cosine equal 3 minus root 10? So I'm going to go to y equals, hopefully you can see this, and I'm going to do a cosine x. Okay, so cosine x. I'm also going to get out of here and I'm going to make sure that I'm in radians, which I'm not. Okay, go back to y equals. What do I want this thing to equal? 3 minus root 10. Okay, and now I'm going to do a zoom trig. So zoom trig. And what's going to happen is it's going to graph cosine. And then what's going to happen is it's going to graph the value that I want. So remember the way that this works is this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. So there are 2 places where these two things hit each other. Okay, where the blue thing hits the red thing. So I'm going to show you one because I'm out of time.